our Careers in STEM panel for today with the Warren County Library. My name is Sandy Roberts. I'm the Makerspace Coordinator for the library system. And today we have an exciting group of people that kind of really, are the gambit of STEM careers. And that is part of what I'm excited about, because I think too often when we think of people that are working in STEM, we think of people either in lab coats in a lab or, tapping away at a computer all day. And I think that there are a lot more avenues in science, technology, engineering, and math than people may realize. So I'm very excited that you're all taking some time out of your Saturdays to be here, and I really appreciate it. So I'm going to give a quick introduction. I'm going to go from my right around. We have Steve Kosiolek. Steve is the Director of Sponsored Accounting and Cost Analysis at Stevens Institute of Technology. And I know that he also has a background both in law and computer science. Nicole Mcpherson is our project manager at Fluor Marine Propulsion, LLC, and works with the Naval Nuclear Laboratory. And Nicole is an accomplished physicist in addition to many other things at this point. And then moving on to Tom Gray, who is an apprentice electrician or inside wireman. I know you have a couple of different titles there, and is with the International Brotherhood of Electrical Workers. And Tom has also very graciously donated one of our prizes today. So we've got a really cool electrician's backpack that you should go and take a look at, because that is definitely a prize to earn badges for. And then last, but certainly not least, William Little is the systems administrator at Procom Systems Incorporated, and also works on the video production at WNTI, the internet radio from Centenary University. So thank you everybody for being here today. I guess if we want to just kind of go in that order right around the screen, because that's what everybody's seeing, why don't you do a little introduction? So Steve, we'll kick it off with you.
Oh, gee, and everyone sounds so much more impressive than me too. Let's see. Well, I'm Steve Kosiolek. I'm the Director of Sponsored Accounting and Cost Analysis. So what that means is I'm responsible for all of the research funding that is provided to Stevens Institute of Technology by various government agencies or private companies that want us to research things. So my STEM background actually started as computer science, and now I spend all of my time sitting at a computer doing exactly what Sandy said not all STEM people do. And I keep track of all that money and making sure it's being spent appropriately. I have a staff to help me. I don't do it all by myself. There's a lot of money there. But that's sort of what I do. I spend a lot of time on computers between various government agencies dealing with reporting requirements, audits, and financial stuff. I started out as a computer scientist. I started out as a system administrator. And through a weird path, I got into research and research tracking management. And now this is kind of what I've been doing for a decade. I have no idea how much more to say about this, so I'm going to pass things off to Nicole. You have to unmute yourself, Nicole.
Yep, I unmuted myself, and then it seemed to have gotten remuted. That's how it works these days, I suppose. So I'm Nicole Mcpherson. I work at the Naval Nuclear Laboratory. I have a bachelor's degree in engineering physics and a master's degree in management. I grew up in rural Pennsylvania, and I got into STEM stuff fairly early in elementary school, but it wasn't really until high school when I settled on physics. I got a glimpse of nuclear physics at the Pennsylvania Governor's School for the Sciences, and I'm pretty sure we've all seen the periodic table. The professor showed us the equation that describes the stability of the atom's nucleus, and now I have my own personal copy of the chart of the nuclides, which is like about 5 times the size, and shows every one that has been made and how long it's been stable and whether or not it occurs naturally and how long it takes to break down. So that's me geeking out slightly. I really love having an elegant equation that describes why things behave the way they do. And that's kind of what led me here. In my career so far, I have operated a nuclear reactor. I've trained lots of sailors. I've done design of ships. I've worked at a shipyard on the construction of ships. I've worked on the Ohio, Virginia, and Columbia class submarines, the Freedom-class littoral combat ship, and the Arleigh Burke-class destroyers, along with their ballistic missile defense systems. So that's pretty cool. What I'm doing right now is being the deputy program manager for the next generation training program. And what we'll be doing is building a full-size simulator, basically the back third of a submarine, in order to train sailors when the current ones run out of juice. Sorry, Steve.
Yeah, I got to admit that is that's going to be a hard one to follow up. But Tom, you're up.
Love you.
All right, good afternoon. My name is Tom Gray, and I'm an inside wireman for the Electrical Workers Union, which is a job primarily focused on commercial and industrial electrical work and construction. And I guess I represent a skilled trade for the panel. And my career path to become a union laborer is a little bit uncommon. Because when I finished high school, I didn't have a great idea of what I'd like to do with my life. So what I knew is I wanted to get a higher education without going bankrupt. I wanted to serve my community and my country. I wanted to see the rest of the country and some of the world. And I wanted to work with my hands so that at the end of the day, I could see a physical object that I worked on, which is kind of an impossible list to achieve. So I joined the Coast Guard and managed to hit a bunch of those things. And that's how I became a machinery technician. And I was able to build a background working with tools. However, that wasn't a very electrically based job. If it had more than 2 wires, I didn't touch it. The electrician's mates did that. And so I learned engines, the mechanical side of generators, flame boilers, all sorts, dozens of pieces of equipment like that. Eventually, I decided to re-enter civilian life and ended up getting a job doing maintenance and operations for a monorail train. And that's where I started developing experience with electrical work, even though I didn't have a formal education in it. And I learned that, well, the civilian world isn't always as safety compliant as it's supposed to be or legally required to be. And we approached the Electrical Workers Union, asked them to explain how they could help us, and we voted to have them represent us on the railroad side of the IBEW. Life took a strange turn eventually, and I moved several hours away to be with the person I loved. And so I needed a new job. And because I worked with it as an activist and volunteer in the union, they helped me switch over to the trade and construction side, which is like the top tier of that local. And you can't just show up and say, "Hi, let me in." And so they put me in their 5-year apprenticeship program. So now I'm developing the educational background to not only safely work with electricity, but the ins and outs and the hard science behind it. So now I'm a 3rd-year apprentice, and my most recent experience has been going through schools throughout the capital region of New York, demoing out really old, outdated, and dangerous equipment because eventually it breaks down. We're installing new. I'm working on transformers, generators, lighting, and extensively on fire alarm systems because I have an aptitude for complicated circuitry, which, by the way, computer science people tend to deal with really well too. It's understanding flowcharts and debugging. Again, you're going to need an understanding of math and science to get involved in it. And if you have questions about that, I'll give you a brief background on that. Now it's probably best to let the next person speak.
William, that means you.
Well, thank you very much, Tom. I'm William Little. I'm a system administrator for Procom Systems, as well as a field technician. I've been working with Procom, which is a public safety communications agency, for a little over 4 years now, about to be 5. And I've been working to not only keep the computers in their office running with the normal troubleshooting of Why is my email not working? Why am I having issues opening this document? But also, I'm in charge of a lot of the IT infrastructure that runs numerous police and fire departments across the state, as well as New Jersey Transit's statewide communications network. I've been involved with designing and building a bunch of different systems on a high level, be it mounting equipment in racks, wiring things, getting cables together, making sure that systems work before we ship them out. But also I've had to figure out what software and what solutions will work, what won't work, design flaws, anything like that, and collaborate with people of all walks of life to be able to make a solution that works and meets the end goal. This all started about, I want to say about 12, maybe 15 years ago, when I decided desperately that I wanted to learn how to host a Minecraft server. I so badly wanted to figure that out. I had some support from my dad, who is also in IT. He helped me at least get the basics, but it was entirely training wheels off for trying to do anything like that. He would help me with the software. He would say, hey, here's Windows. Welcome to Windows. Here's what a network cable looks like. Here's what a desktop computer looks like. And even in a few cases, he would have a few goodies in his trunk and say, hey, here's what a server looks like. This one got decommissioned. Have fun. And I was left with the rest. I learned how to host a Minecraft server. In fact, I got somewhat good at it. For a while there, I was running a creative server purely for people to make structures, and that's it. And for about a year, it was within the top 20 servers in the US that people were joining and interacting on. Now that has moved along a fair bit. Minecraft is Java based, so I had to learn what it's like to run with Java and what it's like to figure out plugins and what it's like to configure them. And that snowballed quickly. And on top of that, needing to figure out how to squeeze as much lemon juice you can get out of a lemon, because the servers that are decommissioned usually aren't that great. So I had to figure out, how can I get as much performance out of this as possible? So I was figuring out networking. I was figuring out using freeware and moving from Windows to Linux and needing to evolve and push forward to do what I wanted to do. On top of that, for a while, I did have a great interest in audio video work, and I thought that the IT side would work perfectly in that. It did for some time. Unfortunately, WNTI moved in a different direction, and so did I. But I was previously a fill-in on-air host, as well as one of their editors to edit any pre-recorded shows as well as their commercials. And I got into that just by volunteering. There was a volunteer position open at the radio station, and they were looking for somebody to learn the ropes and do as much as they can. But really, at first, they were looking for somebody to handle a little bit of the day-to-day, getting the mail, sorting the CDs back into the CD library. But that evolved. Over about 4 or 5 years, they hired me on, and I became a part-time editor. And I'm very thankful for that. That helped me push my skills as well. That and the server work evolved into me getting the position over at Procom Systems and starting up just as their system administrator, handling the day-to-day. But as anyone might find, as you get more into a job, it can get much more complicated and much more can be handed to you. So I had to learn quickly, hey, here's a statewide network that has to be maintained and worked with. And it handles the radio traffic of 3,000 or 4,000 buses. Make sure it keeps working. And so I had to learn on the job. And I think that that's one of the best ways to learn, if it's not in your own interests or your own hobbies, to learn on your own. On-job experience is fantastic. With that, I think I've babbled enough. So I think I'll kick it back over to Sandy. And thank you so much for the opportunity to be able to speak today.
Well, thank you so much for being here. I really appreciate it. And I will give full disclosure. I am actually I was a biochemist way back in the day when I used to get to play in a lab all the time. And that's actually how I know some of these folks, because we went to the same school. And my own story is a little different after working in chemical biology and working in immunology and being the person in the lab that knew how the computers worked. So I ended up being the one that developed the email server and that wrote the website for the company and stuff. I ended up having kids and deciding to go into STEM education, which is what I've been doing for the last 13 years. So I've been very lucky to have that opportunity to switch careers and still get to do what I love, which brings us here today. So as you were all chatting, and I do want to let everybody know, if you are watching, feel free to send in any questions that you have. I'm happy to ask. I can always unmute you as well. But I actually had a couple questions just kind of listening to everyone. And it seems like you all had really different paths to get to where you are. Like some went to college. I know some got advanced degrees. Some did on-the-job training. Some, have taken kind of a different route and didn't do any higher education, but rather went skills-based and did apprenticeships. What are your thoughts on that? What possibilities exist for kids today? And what would be your recommendations for maybe kids in high school right now trying to either avoid expensive education or, looking for the best opportunity out there? What suggestions might you have? Nobody wants to start.
I'll start.
Okay.
If you're looking for a career, it has to be something you enjoy and will continue doing repetitively for a long time. So if your heart isn't into a career path, don't go for that out of some sense of obligation. I was taught you'll never amount to anything without a college education, and you have to do this and you have to do that. And it's like, I was told a lot of things that pointed me in directions that did not make me happy. So, if you don't find that career, because clearly I'm on my third now, it's okay. And don't be afraid to walk away from a career path or an education path that isn't right for you. Sorry, moms and dads out there, but not everything is achieved through college. College is a wonderful thing. It's not for everybody. Don't be afraid to do a vocation, and don't be afraid to do an apprenticeship.
I think that's really great advice, because college isn't for everybody at all. It worked, for me, college was great. For my sister, not so much. Wasn't something that made sense for her. Even with my own kids, I've got one who is probably going to be college track and another who is already looking for internships. She's in her final year of high school, and college is probably not what she's going to want to do. But I think you made a really great point about, if the job isn't working, if the career isn't working, if the educational path isn't working, if you aren't loving it anymore and you have the ability to switch, not everybody may easily be able to do that. But if you have the ability to change that path, I think it can be really empowering to do so. And I mean, as someone who did that, I think it's definitely something that's important to do. Anybody else? Thoughts?
If I could answer that, or at least offer my opinion on that. So I'm currently 25 years old, and I am still working on, I call it slow boating, through a bachelor's degree in information science and technology. Being in university has been a great opportunity, especially to learn online, which is a fair bit more flexible thanks to this day and age of information technology. Being able to learn online is fantastic. And so that has opened a lot up, but I'm still working on that degree. I haven't had an associate's degree to show around. I've only had my high school diploma, and I didn't even earn that in a normal manner. I earned that with the 30 college credit equivalent program that the state of New Jersey has, where I started over at Warren County Community College early. I left the technical school that I was at early and went over to college. And I was accepted into the community college, and I was able to earn my high school diploma that way. And that was great because it allowed me to focus on what I wanted to focus on. And there was a lot that I was looking at the time for multiple career potentials, both the potential that I had at the radio station, WNTI. That was a great opportunity for many years to learn about audio and video work, as well as applicable computer maintenance and science in general, because we have to handle a bunch of data and we have to have reliable internet connectivity, correct network routing. There's a lot that has to be done, and done in a applicable manner instead of theoretical. At the same time, I was working on the farm. I do live on a farm, and so I had to take care of animals, and there was a lot to do. So it was great to have the extra time away from college to work on that. Since college, unlike high school, you could more or less choose your hours, which adds great flexibility when you're looking to get into a trade or an internship, as far as I see, in my opinion. And then in addition, I was running Minecraft servers and all kinds of other things at the time, racking up the electric bill for my folks as I was running all kinds of hardware in the basement. And I was exploring all these different avenues, figuring out what I wanted to do. And I found that having that flexibility straight out of high school made me the person that I am and gave me the opportunities that I have. So I greatly appreciate the opportunity to not go to school full time, but that's what worked best for me and my path. This is not necessarily a guarantee, but I do see it as a great way to go if you already have a general idea of what interests you and excites you. And if there's multiple things that interest you and excite you that you think there's even a chance of becoming a job or a career, then I'd say that that's exactly what you need to start out the gate with a good pace to find your way and build yourself up.
Yeah, I think that's, that's something that I think sometimes we forget, is that you don't have to go and attend college for 4 years on campus and do a traditional program that way. So I think that you bring up a lot of good points that you can kind of make a program that works for you,
Absolutely.
Nicole, Steve, you work at a university. You got anything to say here?
Well, with that said, absolutely go to college. We need the money. Okay. No, seriously. And I also have 2 kids, as you said, and one of which is almost certainly college track, but the other one is probably not. It's a matter of, again, finding, Tom was right on the money with this, find something that you're going to enjoy doing every day for the next 40 years. And that sounds daunting to a 8-year-old or an 18-year-old or heck, a 48-year-old. But that's really what this is. This isn't my first career. I started out as a systems administrator, as a programmer. I went to law school. So I have actually 2 degrees, which law school teaches you to think a certain way. So does regular college. And that way of thinking is very helpful and important for certain careers. The career I'm in now is not something I could possibly be doing without the background I got both in law school and in college as a computer science major. But I'm almost uniquely qualified for it. There are a couple hundred people in the country that do the sort of thing I do. And that makes it interesting and fascinating, and something I enjoy doing every day. It is certainly not something I'm going to say I expect either of my kids to be interested in even a little bit. I barely have my wife interested in it even a little bit. But it's, it works for me. And everybody needs to figure out what they want to do. And also, just because you're doing a job in one thing doesn't mean you can't keep tinkering in other things. I have this cool virtual background behind me. That's actually my Christmas tree, which I program every year. Every one of those lights is individually coded. No, it's a pattern. It's not that I code 500 separate lights one at a time, but it's a project for me. It gives me something to do that keeps playing in that original field of computer science and programming. And so keep your hobbies too, and sometimes keep them separate from your career, because they're far more interesting when you don't have to go to do them every day. So since I've talked enough, it's somebody else's turn. Nicole, if you want to say something, or it's back to you, Sandy.
Sure, I'll jump in for a bit. Trades are a good way to go if you like to touch things and if you're not interested in college. if you are interested in college, Steve will really appreciate that. So, thank you for attending. And, somewhere there is the middle path. If you are going to putter and work on perhaps an associate's degree, since that helps you get places too, try to make sure that it's an Associates of Sciences, because for some reason, my company doesn't like hiring people with associates in arts, which boggles my mind, but it just means it's a little bit heavier in math. And that is a way into companies. And I guess you could also do a stint in the Navy, go Navy. My sister spent 12 years in the Navy and then came out to get her PhD at Penn State. So many paths.
I think that's probably the most important thing that I try to tell my students, and we have to remind kids and parents that are listening, please remind your kids that there are so many different ways to find that career that gives you a reason to get up in the morning. So talk to me a little bit about why STEM fields are important. I mean, I know we hear about it a lot, but I don't feel like sometimes it's just like, well, STEM is important. Obviously, we all have smartphones, but I feel like it's probably a little more than that. So maybe, and I think that we have kind of a wide enough experience here too, to really talk about all the ways that these fields influence our lives. And, maybe some of the things people might not realize are STEM fields that are STEM fields. So if anybody wants to share on that. No?
Yeah, I'm straight up STEM the whole way. So I don't know what fields are STEM fields, but don't look like it. If you want to see some practical aspects, I worked on the ballistic missile defense system. That uses a ship with a radar to look very tiny object in the exoatmosphere and then throw a missile that doesn't even explode. It's just like a chunk of metal with a pointy nose and hit that thing several miles above the atmosphere of the Earth. It's good if some of your not so friendly people on the other side of the planet want to lob intercontinental ballistic missiles at you. It's also good if you're just going to have a satellite that's going to spiral down. You're like, how about we just knock that off base and get it into the ocean instead of have it accidentally hit Florida, which I think is what we did in 2006. 2006 sounds about right. So there you go.
I think it's really important that you bring up a couple times here, and we've seen this a couple times, is that the influence of the military, the importance of the military in STEM, and the fact that so much of our STEM fields do really support our military in a lot of ways, and a lot of research goes into military applications. So that's certainly something for kids to be aware of and parents to be aware of. Tom, you look like you're unmuted.
Yep. So my thoughts on STEM careers and why it's important is that things can get really out of your control and expensive fast when you don't apply critical and scientific and logical thinking. Sometimes they get really dangerous as well. On the more expensive side of things, I once had to go do emergency work at a restaurant that hired the cheapest labor around, the cheapest electricians, who were people who were just trained in the field as a residential guy, working on people's houses. They were handymen. And this restaurant was threatened with a closure by the local inspector because if they didn't get their restaurant up to par after the poor quality of work that was done. And, now they had to come to us and pay emergency rates because they needed educated people who do that commercial stuff. And, they're basically paying for the job twice. They were paying the cheap price first, and then the cheap price came with fines and the threat of losing your ability to operate. And then instead of paying our regular rates, they had to pay us double time because we're working there from 11 o'clock at night until the job is done to get this restaurant up to snuff. So, and when you have these issues, you don't know what that handyman's done you know, he could set your building on fire. You know, that's bad, obviously. So, you know, like I said, it's that STEM background. It can save you money, and it could keep you from losing your business, and it could keep you from hurting people.
That is a really good point. And, you know, I think in general, and this kind of came up in the previous panel, was just the idea that like computational thinking and the kind of scientific thinking that you develop when you are studying STEM or when you're working in STEM is a good way, is a useful way to think through so many of life's problems, so many of the challenges that anyone is going to face. It doesn't matter what field you're in. And I think when it comes to, you know, risk analysis, for example, or even, you know, making medical decisions for yourself or your family, having any kind of a STEM background is going to make that just a lot easier because of the mode of thinking. Will, you look like you have something to say. I feel like you have something to say.
Actually, the critical thinking had me thinking of a not always so thought about portion of STEM and general hands-on trade, at least maybe for this particular audience, which is automotive repair. And I remember critical thinking playing a interesting but unfortunately too late role when, for a small example, my mom's car needed a new alternator, the part that generates power from the engine to recharge the battery, run your headlights and all that. That piece had failed and it needed to be replaced. And that piece is just held on by 2 bolts right at the surface level when you open the hood. So it's easy to get to. The dealership wanted about $700 for that repair, somewhere in that ballpark. Unfortunately, I was about 5 minutes too late between the time that my folks had texted me to let me know about this and my responding text message saying, by the way, that exact same part number that is Honda's exact spec for that part is $120, and I can pick it up in town today. That to me is one of the simplest and smallest views of critical thinking being a money saver and a time saver, where you can think through something and say, this is something that I might be able to manage or can definitely manage or have managed it before. I'm willing to, in the way that Nicole said it, trades, if you're okay with touching stuff. If I'm okay with touching this, then I should be able to work on this. And unfortunately, the car had already gotten into the clutches of the dealership and the order was in. But that's just one of my favorite examples of critical thinking above and beyond IT and all the other communications work that I could talk about. I'd say that's the best example I have.
All right, Steve, do you have anything that you wanted to add to that thought?
Well, I know you were asking about STEM things that don't really seem like STEM, and I think since I see a lot of research coming through my office and at a high level, I don't know how much I can talk about all the time, but I do know there are a couple of music awards that we have gotten from actually the Department of Defense and DARPA on doing collaborative music stuff, because music is a lot like math, and interfacing with computers through music is something that is sometimes faster than trying to do it with a keyboard. I haven't looked into it a lot, but those of you that love music, there's actually research work out there for real world applications of what to do with music other than make people happy. And you know, that's just one example that came to the top of my mind. I'll let you continue from there.
Yeah, I think that's an interesting point. And that kind of came up a little bit in the educators panel too, is that, yeah, we think of, again, you don't want to get too narrow about what you think STEM is, but I know that you've seen all kinds of, you know, even climate change issues in all kinds of different ways. You know, a lot of music, actually, the entire music industry, the entire movie industry is powered by STEM at this point. That's all code. That's all electronics. That's, you know, that's the art is important, but none of it would get out there to the population if it wasn't for those in STEM fields making it happen. It kind of came up, Steve, you brought it up as the not giving up your hobbies. So do any of you have hobbies that kind of either give you a break from what you do all day, that kind of give you the mental break, or hobbies that are maybe in different STEM followings that you don't use on for your actual work? Just curious. Now I'm going to pick your brains.
Well, I'm still running Minecraft servers. I do still run the exact same, well, newer hardware, but I still run the same mentality-wise system that I used to run many years ago. I still have servers, thankfully more efficient, not making the power bill crazy, servers for me to tinker around with and just have fun. Gaming servers of different types, a couple of web servers, things that I have used as learning tools that can sometimes help me for work. Occasionally, I do bring work home and work on it on my servers here, but also a lot of fun. Being able to do something like make a change on the server side that may seem very technical, changing a script, adjusting a configuration file, and then being able to compile that and say, great, time to fire up my game, and be able to have some fun with friends and some time to just wind down and relax while still doing something I enjoy, which is generally tinkering with servers. That brings a lot of happiness, and it's a great hobby to go into that I try to keep out of work, and I try not to do excessively often so I don't get burned out by it.
Okay. All right. Tom?
Yep. So I do some tinkering too, though I'm more of a hardware guy than a software guy, apparently, obviously. And, some of it may not seem that STEM-like, but, I build things like owl boxes, bird houses, bee boxes, and sometimes a more efficient rodent trap. We're a little bit inundated with a rodent problem outdoors here because people release them in a children's park across the street. It's awful. But, so you have to think in terms of, well, owls take care of rodents, so maybe I can build an owl box and entice them to live here. And so you need to figure out where they like to live, the dimensions of the things they like to live in, how they come across, when their mating season is, when their nesting season, and of course, basic math, because, seriously, most useful tool ever. It's why I get paid the big bucks. And, again, when you're trying to figure out, well, right now the problem is these deer mice, and the chipmunks and squirrels keep eating the bait, so the traps can't deal with the deer mice. So now I need to figure out how to build a better mouse trap. So I need to figure out how they find food and what areas they like to walk in and why, and how they use their whiskers to see because they're nearsighted. And, things of that nature, and how to direct them and funnel them directly to the trap so you don't have it go off and, they walk away with your bait. And so, those things are STEM-like. People like gardening. We have a bee shortage in the world now. So how do I make a box that promotes bee growth? And what size holes do I need, and how far apart should they be, and all that stuff. And again, that's back to your tape measure and learning about insects. And so, yeah, these are my STEM related hobbies that don't quite seem like STEM.
No, I hear you. Steve knows I can get a little obsessive about my gardening because of the chemistry and the biology, and I want to make sure all the plants are, yeah, I get it. Anyone else want to share any hobbies that kind of keep them sane? Nicole's like, who says I'm sane? So, we've got about 9 minutes left. I want to kind of ask, if you could do something over, or maybe make a different choice, are there any, or just give a warning in general to those that are thinking about going into these kinds of fields? What might be that advice? What might be that cautionary tale? No one? That's actually really great. Okay,
well,
William.
Actually, sorry to be the talker. I have learned that allowing yourself to fail and pick yourself back up, I know that that's a relatively universal thing to think of, but having a failure, having a bad day at work, not being able to do what you intended to do for your work. In my case, maybe that's getting a tower site up and running, or it's making sure that a data link is functioning as it should, or a server just crashed and I wasn't able to bring it back up in that day. That's okay. Or even not knowing what's going on, what I need, the steps that I need to take, not knowing and having failures occur is not only possible, it's likely, but it's totally okay. I've learned that as long as you're okay with brushing yourself up and seeing where you're able to improve or change, or just figuring out what you needed, so that if you ever find yourself in a similar scenario next time, you're a little bit more prepared, that's golden. So learning through failure, except maybe in Nicole's case, sorry, Nicole, is a great thing.
No mistakes for you, Nicole. Sorry, no, not to put the pressure on you there. Yeah, I mean, I'm very deeply entrenched in the maker movement and all that. So learning through failure is a big part of that. Anyone else have anything that they want to share? Tom.
Yeah. So one of the more smart aleck things we were saying in school is, why do I need to learn this? I'm never going to use this math again. And now, well, that math is why, and you know, I wasn't really great by the time I hit my senior year. I was just done with it. And, you know, it's like, it would have been a lot easier for me to figure out a lot of this pipe bending lesson and this AC theory lesson if I had actually knuckled down and learned trig a little bit better. You know, because in the end, everything boils down to, with electricity, two equations. That one is for voltage, and that one is for wattage. And combined, that's about 90% of all the math in electricity. Gets a little bit more complicated when you do phases, but it still boils down to those equations. You know, the Scarecrow's thing at the end of The Wizard of Oz, the isosceles right triangle, right? Well, any right triangle, really. It seems stupid, but believe me, it came in handy.
Yeah, I guess you never know what you're going to end up needing. So, you know, you got to, you know, if somebody had told me back in high school that all those English classes that I was really bored in were really important, that might have been a good thing. But I wish I had spent a little more time learning to write a little bit better, since I do that like an awful lot nowadays.
It also occurs to me now, years after I left the railroad, I also used those triangles to make sure the brakes were working properly on the trains.
Oh yeah,
Very important piece of information.
I bet. Steve, you're unmuted. What would you like to share?
Well, to continue with what Tom was saying, all that stuff you say in high school, why do I need to know this? And he said math. I'm going to say English and writing. I think I spend more time writing memos to people and responses to government auditors than I ever thought I would write ever. So all of that stuff you're learning in high school, learn it. You may not use it, or you may. I don't think I've used any of the stuff in the chemistry class for anything other than I feel like blowing something up tomorrow. Small and in the backyard, not like buildings. It also gets harder to learn as you get older. So just finding the time when you're younger to do things. But the biggest thing I think is, don't be afraid to say, you know, this was a good idea, but I should really do something else now. Switching careers has made my life that much better over time, and I've done it a couple times. And if you do it when you're looking at this and saying, I'd like to do something else, well, learn something else and go do something else. And do it on your terms. Do it while you have the ability to do that. If you need to keep going to the job to pay the bills, fine, but learn something new and go try something new, because sitting at home and doing the same thing over and over again and getting miserable is exactly the opposite of what we want to be doing as makers and as people.
Yeah, that's good advice. I forget what the estimate is now. They're saying that kids coming out of school now are likely to have up to 20 careers over the course of the time that they're working. So it's like that's going to be, more and more normal, is switching careers. And so being as flexible as you can and just banking those skills either in school or on your own time is worthwhile. All right. Unless Nicole wants to share on that.
I still work in a place where there's a large number of people that have 15, 20, 25 years. A couple people who've been there 40.
Wow.
But it's a really narrow field. And even when I've moved to different parts, I keep running into people I knew in the nuclear community everywhere. I went to Wisconsin. There's one right there. There's two of them. Why are they in Wisconsin? Why am I in Wisconsin? Well, because we build ships there.
It's funny that you do kind of find these communities of people that you do run into over, especially as you start to specialize more and more. I was on a panel last night, and I was like, oh, I know you and you and you, and oh, okay, well, we all know each other. Great, Okay, very last question. This is the lightning round here. What's the future? What is coming next that people should be paying attention to? What's the next interesting STEM field? Tom?
Green tech and power generation, specifically solar and wind. There's a lot of people who've been naysaying it for 20 and 30 years, but right now, the US is finally catching up to the rest of Europe, and that is where the money is going to be in the future, and it's growing more and more each day as states are subsidizing more and more solar fields and wind farms. So there's going to be a lot of work, especially over the next 10 years, for people who want to get that hands-on experience and start in a field that is relatively new and is cutting edge.
Wow. Yeah, that's a great point. Anyone else? William?
I'd say smart cities, and as science fiction as this is going to sound, multi-planet communications. So smart cities are starting to become quite prevalent. You have multiple vendors now trying to make it so that traffic lights can intelligently change their timings to improve traffic flow, and crosswalks that know exactly what's happening 3 blocks down the way. Systems that can automatically route traffic if there's an incident or a closed road. All kinds of things that are now happening in cities, and it's starting to become a bigger and bigger industry. Interplanetary communications, as science fiction as that's going to sound, while that is generally a STEM field working on the technology and radio frequency theory or RF theory, it's going to be given quite a twist when we bring multiple planets into play. A company that I work with, Nokia, that they now own Bell Labs, a very famous lab here in New Jersey. They just got awarded the contract to build a 4G cell phone tower or cell phone network on the moon. And so they are now being contracted to build the equipment and the infrastructure that could be set up on the moon to provide cellular communications. So there's a lot of interesting things that are like that are probably going to happen within my lifetime at least. Definitely anybody else's lifetime that's younger than me. We may be seeing communication systems on Mars and relay stations throughout the solar system. There's a lot of interesting talk on what communications is going to look like as we become a multi-planet species.
Wow. Yeah, I keep forgetting that. Yeah. People your age, kids coming out of middle school and high school right now, that's going to be part of their reality. And that's kind of wild to think about. Anyone else?
Additive manufacturing.
Oh, yeah.
We've been looking a lot into that, and I don't mean just the plastic stuff. We're looking at metals, and then the material characteristics of things that you've manufactured in an additive manner. This is both for new things and really important for manufacturing things that you need repair parts for, but haven't been made in like 2 decades.
Oh, yeah. Wow. That's a good point. Yeah. Those parts aren't just sitting on the shelf somewhere. Yeah. Yeah. And it's way beyond 3D printing, way beyond what people are doing on their desktops. And I imagine material science has got to be really important for that.
Yep. It's a place to start, though. I mean,
And that's true. Starting with 3D
one
printing.
of those in your living room or your library.
Yes, we do. The library does have 2 3D printers available for the public. They're both sitting right over there at the moment. Steve, anything you want to weigh in on before we finish up?
Oh, things that are whacking us around right now are things like cybersecurity is a big one.
Yeah.
We're talking about multi-planet networks. We need to really worry about how do we keep them running and unhacked. A lot of companies are dealing with cybersecurity right now as hackers are becoming more and more into that encrypt all your files and ransom them for money. So that's really a big current field. Other than that, there's a lot of biotech integration stuff like exoskeletons or even just repair of the parts you already have and how do you keep them working for 80, 90, 100 years, because our bodies aren't really designed to last as long as our brains are starting to.
That is a very good point. And actually, I will put a quick plug. Our next speaker is Bia Scilab, and she is a young hacker who's very involved in cybersecurity and election security. So those folks that are watching now, you may want to stick around for that talk as well. Well, I want to say thank you so much for giving me this time and giving the public this time, for answering all my crazy questions, for sharing what you do, and for being just general good sports. I really appreciate it.